Good morning, everyone. It's day 6. We are so back. Winter break has ended, and that means, well, the grind never stops. Here we go. Merge to two sorted lists. Let's do this one. One other thing, yesterday I was looking at all of my things so far, and I realized hey, each one of these questions is taking me an hour and a half. Not really, maybe around an hour, which is fine. And I looked is there a more efficient way of making sure that I was getting everything. Is there a more efficient way of me doing these questions? And they basically said that if you can't figure it out, look at the editorials. Oh, I need to have premium. I wonder what the editorials even are. But yeah, they said basically look at the editorials, and I did not know. I don't even know what they are. Yeah, basically 30, 45 minutes, and then look at the editorial. I can probably find it online. Whatever. Let's get started. You're given the heads of two sorted linked lists, list 1 and list 2. Merge the two lists into one sorted list. The list should be made by splicing together nodes of the first two lists. Return the head of the merged linked list. Okay. Okay. Here's what I'm thinking. I think I'm just gonna. Oh, this is one of those sort linked list questions. If there's two lists, like that, they have different things. I should be able to just merge them into one, and then sort them. Give me my answer. Right? I think so. Oh, that's not good. List. Let's try that. Need to give myself a refresher. might even be better. Intuition behind the given solution comes from the fact that both list 1 and list 2 are already sorted. The algorithm can take advantage of this by comparing the nodes from both lists and choosing the smaller one to be the next node in the merged list. Of this by comparing the nodes from both lists and choosing the smaller one to be the next node. Oh, okay, that makes sense. That makes sense. That seems to be a lot better. Yeah. All the remaining elements in the non-empty list must be larger than all the elements already merged. The non-empty list must be larger than all the... because the lists were sorted, so we can simply put the next. Okay. Yeah, bro, look at this. It's not that bad, to be honest. the Sentinel node. So I'm guessing that's what it is. Oh, it's not bad actually. Oh, this is the dummy node, I'm guessing. Okay, bro, like, that's not what I want. Okay, so let's just like go to the side. So it's creating like, okay, one node, no value. It's not pointing anywhere. Oh, this is amazing. Oh, so the Sentinel node is like even before. It's like, oh, okay. So I think it's like the sentinel node is like even before the first node, right? Sentinel exists first. Okay. Node one. Okay. Well, list one and list two. So while they're both not empty, like we want to basically return whichever one is smaller and add it to the sentinel node, right? Oh, it's just straight up doing that. Okay. If list one dot val is less than or equal to list two dot val, is it like current dot or current dot next equals just one, and then current equals current dot next. No, it's list one. Oh yeah, because doesn't make sense. Oh, okay. I see. Then it'll be like else. If it isn't, then current dot next equals list two. We're saying current dot next equals list two, and not, because I was thinking it should be list one dot value, but no, we literally want it to be the full the actual list node. List 2, and then list 2 equals list 2 dot next. Right, so after it picks one or the other, you want to move it. That's what I was trying to do before. Current equals current dot next. Move it to the next point. And once you move it to the next point, go again, go again, and go again. Okay. If list 1 exists, then current.next should equal to list 1. Otherwise, current.next should be equal to list 2. If list 1 exists, that means it's not. If list 1 is not pointing to none, I guess. So it's like, I guess I just move it here. So basically, okay, we have we have list 1. It's sorted. And we have list 2. Right? And we want to basically merge them together. So first thing that we do is we make like a dummy node, or it's called a sentinel node, like that. And then what we basically do is we run a comparator. So let's say this is called 1, 2, 3, 4. This is 7, 8. No, maybe we should make this better. 5, 7, 8. This is 3, 4, and 9. This is a 4, 9. Okay. So this is initiating this, and this is just like kind of going like, this is my current node. Okay. Then what we do is we basically run a loop on this right here, and we keep going until one of them runs empty. And this is what we do. We basically just compare. I'll change the marker. Okay. We just go, okay, let's compare these two. Which one is smaller? Okay, so list 1 is smaller. So let's add let's add 1 because 1 is smaller. Okay, now that's done. Now let's compare like this. And then after we do that, if we find that this is smaller, we move it to the next, right? Okay, which one is smaller? Okay, now 3 is smaller. So maybe I should use a different color. Wish I could like change this. Okay, it's fine. Let's just use like 3 is smaller. So we go here. Then next. Okay, now, we also move this to here. Then we compare these two. Which one is smaller? We find that 4 is smaller. Okay, put 4 here. Next. Then we move this here. Okay, now we compare which one is smaller. Like that. And we find that 5 is smaller, so we go 5. And then we move this over here. And then we compare which one is smaller. 7 is smaller, okay, so we move 7. And then we move forward. And then we compare, okay, which one is smaller? 8 or 9. We go like this. And then we find 8 is smaller. So we go 8. Let's also just add one more here, like this. How would I show like one of the list is empty? Yeah, I'll just go like that. Yeah. Wait, no, I should be able to show it anyways, okay. Okay, and then we move this over here, I guess, and then we run. Okay, so now we know like this first list is empty, and we still have this 9 that's left, right? So since we still have 9 left, we just append the rest of the list. So the rest of the list only contains 9 here for list 2. So we just append that entire list onto here. So then we get 9. Should be blue, but it's fine. And this becomes our final list. Yeah, and that's us getting right here. Then what we do is we just return the sentinel, but not sentinel, we return the next to the sentinel. And then this will be the actual list that we return because we return. This is what we're actually returning. That makes sense. Cool. Let's see if that works. Noise. Oh man, too used to C++. Initialize Sentinel, or aka dummy node. Set current pointer to any node. Loop until append this one value to I'll just call it dummy. That makes more sense to me than Sentinel. Point to next node in list one. This only works because both lists are already sorted. It's more like if we are at the end of Okay, let's see if this works. Let's go. Should be pretty simple. Time complexity should be O of n, because we are just adding things. Basically, like, if list 1 and list 2 together, because like if list 1 and list 2 have n number of inputs, at the worst case, would it be n? Yeah, because like, yeah, so since if they at the worst case, if they both have like n number of inputs, you're going through both of them at the same time through one loop. So it's still O of n, and then the if else is just like negligible. It doesn't really do anything compared to the loop, and there's only one loop, so it should be O of n. I think space complexity. No, you can have as many nodes as you like, right? So, like, nodes can grow. I think this would also be O of n. Let's see. N plus m. Yeah, because we're adding them together. Makes sense. O of 1. Oh, because there's no, you're not adding anymore. But I thought, no, because it's just pointing. Oh, okay. Dude, that's cool, yo. Okay, that actually makes sense. I should make this n plus m. N plus m. Ouch. other, no, rest. And the rest of the other list to the current node. Damn. I think we did pretty good today. I think it helps to look at the solution, especially like for me, since I haven't done data structures in like I would say in a couple of months. Because it helps me refresh, and there's sometimes like this one wasn't a new pattern. I think I learned the same one in class as well, just like conceptually but not actually like coding it out. um, so I think I grasped this one a little bit quicker than the other ones that I've done. So, well, good news, we are good. Day 6 complete. See you tomorrow.